Hey, what's up guys? Welcome back to another video of Stonks Maxxing. So, we are oh, day 97 of Stonks Maxxing. Don't have too much time. I have about 15 minutes before my next class, so going to just kind of speed run through a few different articles. I think this one is probably under a paywall. Yeah, it is. Information, I feel like they're a really good publication, but it does cost like $300 a year. Corporate AI spend. Ventures, presidential agenda, Sarah Guo, VC at Conviction Capital, I believe. Yeah, man. Okay, maybe I can just get some read-throughs from the headlines. Alright, Andy Jassy. I forgot the CEO of Anthropic's name. But let us... So this is the Klaviyo from yesterday. Our notes. Let's see if we can just jot some stuff down that we find interesting. Okay, so the information Open AI is moving from GPT models, so generative pre-trained transformer models, to reasoning models, which I don't really know how that actually works. I remember O1 stands for the O1 visa, which is pretty cool. But let's think about, so how do reasoning models work? And exceeding human PhD level accuracy on a benchmark of physics, biology, and chemistry problems. Okay, so the O1 model introduces reasoning tokens. The models use these reasoning tokens to think, breaking down their understanding of the prompt. So I think if you look at the GPT models, a token could be a word, any word in a sentence. I'm trying to remember what I learned about in my deep learning class. So any token could be a word. And I think there's this idea of attention, which is a really core concept in transformers, which is kind of like the underlying algorithm that GPTs use. So I think the attention is you have a key, a value, and a query, and it's just a bunch of matrix multiplications, I want to say. So I don't fully remember exactly. I remember cosine similarity is also related to this. I think cosine similarity is just straight up the dot product between, I'm trying to think, if you have two vectors and you were to calculate the cosine of the angle between them. yeah, I have to refresh on that. But okay, so instead of using, I guess, these just straight word tokens, now they have this idea of reasoning tokens. So the reasoning tokens to think, break down their understanding of the prompt, considering multiple approaches to generating responses. After generating reasoning tokens, the model produces an answer as visible completion tokens and discards the reasoning tokens from its context. So I think that context is really just that context window or that chat box that you can actually type things into. Here is an example of a multi-conversation between a user and an assistant. Input and output tokens for each step are carried over while reasoning tokens are discarded. So input 1, output, that's fed into the input of truncated output. Okay. So it's important to ensure that there's an upper limit on maximum number of output tokens. This includes both the invisible reasoning token and the visible completion token. So I guess the reasoning tokens are invisible. Few-shot prompting or instructing the model to think step may not enhance performance, can sometimes hinder it. Okay. Oh man. I remember learning about this. So few-shot versus zero-shot. I think few-shot is maybe giving it a few examples as maybe a baseline so that the model itself could take a look at these examples and then frame an output that would match that. I think zero shot is you just do whatever you need to do. Can you draw me a picture of a cat? Or can you answer this physics problem without giving it any help? I think that's the idea of few shot versus zero shot. Prompting the things is unnecessary. Okay. Okay. Coding, refactoring, coding, planning. Okay, so I think this is a very interesting way to... I haven't been doing this whenever I prompt O1, but just having this instructions and then bullet point after bullet point, I think that's pretty helpful. Okay, so I guess this would be very interesting to kind of write down. So these reasoning models use something called a reasoning token. It seems like these reasoning tokens are used in the context window of O1 and help the model think through problems. Right, that's very abstract. I think I am sort of being hand wavy here. I don't fully understand exactly what it is. Okay. So I guess I can add this here though. reasoning tokens are discarded after they are used for thinking through an input. Okay, so that's very interesting. I think Meta VR. There's something creates digital twin. Interesting. There's also I do have something to keep track of all of. I don't know where I put it though. Is it in AI? Superclusters. Okay, AI accelerators. Right. I want to understand who is making AI accelerators and what are they and when are they going to go into production. I think Meta's MTAI, so this is an AI accelerator that Meta's making. I'm assuming for training their llama models. Training and inference accelerator. It's being built with AI in mind, including new generative AI, Gen AI products and services, recommendation systems, advanced AI research, and it's an investment we expect will grow in the years ahead as the compute requirements to support AI models. So this is March 2024. Okay, this is actually very interesting. I don't know what these things are, like the cluster 1 plus cluster 2. I guess this is all NVIDIA stuff. Hundreds of trillions of AI model executions per day. Service based on YV3 Sierra Point platform. I don't know what that is. Open Platinum. Okay, so it's part of the Open Compute project, which I'm assuming is some type of open source. Latest VIA home Linux file system backed by Meta's Tectonic storage solution. Okay. That will include 350,000 NVIDIA H100 GPUs as part of a portfolio that will feature compute power equivalent to nearly 600,000 H100s. To lead in developing AI means leading investment in hardware infrastructure. Hardware infrastructure plays an important role in AI's future. Today, we're sharing 2 details on our versions of our 24,576 GPU data center scale cluster at Meta. Okay. I remember looking through some articles about how much power does it take to power a data center, or how much energy does it take to power a data center. And I think that number is insane. Like upwards to 50 to 100 megawatts at any point in time. I think if you were to convert that to gigawatt hours, that's around 300 for an annual amount. So you're consuming 383 gigawatt hours for a single year. That comes out to around 50 to 100 megawatts at any given time. I think that's equivalent. This is a statistic that's been thrown around to powering 50,000 homes. It's around that range. It's a lot. Yeah, it's a lot. I can see why a bunch of energy stocks are really outperforming. Yeah, AGI, when it comes, it comes. I don't think anyone really knows what that actually means. Okay, so that was this is actually pretty important, and I do want to read through that. So I know, so what's Amazon's AI accelerator? And then I think I do have to go. Tranium. Okay, that's what it was. AWS Tranium. Is it AWS Tranium? Or is it Amazon Tranium? Okay, that's cool. I think this is also built by TSMC. Everything is built by TSMC. All right. So with that being said, I thank you guys for tuning into the stream. I think this is very interesting, but my screen is frozen the whole time. That's unfortunate. Yeah. Well, I think we talked about some interesting stuff, and I gotta go to class. So